Quantum physics, exploring the key concepts and theories. We'll take a look at the basics of quantum physics and the key concepts that define this field. Quantum physics is a branch of physics that focuses on the behavior of matter and energy at the subatomic level. The key idea behind quantum physics is that energy, matter, and time are not continuous and constant, but instead exist in tiny packets or quanta. This has resulted in some strange and seemingly paradoxical phenomena, such as superposition and entanglement, which have challenged the way we think about the physical world. One of the most famous and mind-bending examples of quantum physics is the Schrödinger's cat thought experiment. In this experiment, a cat is placed in a box with a poison that may or may not be released based on the outcome of a quantum event, such as the decay of a radioactive atom. The paradox is that, according to quantum physics, until the box is opened and the state of the cat is observed, the cat is both alive and dead at the same time, existing in a superposition of states. Another key concept in quantum physics is entanglement, which refers to the phenomenon where two or more particles become connected in such a way that the state of one particle is dependent on the state of the other particle, even if they are separated by large distances. This means that if the state of one particle is changed, the state of the other particle will change instantaneously, even if the particles are on opposite sides of the universe. This phenomenon has been called spooky action at a distance and continues to be a source of both fascination and frustration for physicists. The basics of quantum physics are the foundation for understanding the strange and seemingly paradoxical world of the subatomic. The double-slit experiment. One of the most famous experiments in quantum physics is the double-slit experiment, which challenges our understanding of the nature of reality. The experiment involves firing electrons or photons at a screen with two slits in it and observing the pattern that is produced on a screen behind it. The results showed that electrons and photons seem to behave as both particles and waves at the same time, and that the act of observation influences the outcome of the experiment. This experiment has been repeated countless times, and the results are always the same, yet they remain a mystery. Scientists still cannot explain why particles seem to know the outcome of the experiment before it happens, or why they change their behavior based on whether they are being observed or not. The double-slit experiment is not just a curiosity, it has real-world implications. For example, it helps us understand why quantum computers are so much faster and more powerful than classical computers, and why quantum encryption is so secure. This experiment remains one of the most intriguing and mysterious experiments in quantum physics, and it continues to challenge our understanding of the nature of reality. Schrödinger's cat. One of the most famous thought experiments in quantum physics is Schrödinger's cat. The experiment describes a scenario where a cat is placed in a box with a lethal poison that will be triggered by a random event, such as the decay of an atom. According to the principles of quantum mechanics, the cat is in a superposition of states, both alive and dead, until the box is opened and the state is observed. This highlights the strange and counterintuitive nature of quantum mechanics and the limitations of classical physics. Another interpretation of Schrödinger's cat is the observer effect, which states that the act of observation changes the state of a system. In the case of Schrödinger's cat, simply opening the box to observe the state of the cat changes the outcome. This phenomenon is known as wave function collapse and is a central concept in quantum mechanics. Schrödinger's cat highlights the limitations of classical physics and the need for a new framework to understand the behavior of the quantum world. It shows that the universe operates under different rules than those we observe in our everyday lives, and that our understanding of the world must be expanded to include these strange and mysterious phenomena. By exploring and contemplating the strange nature of Schrödinger's cat, we can gain a deeper appreciation for the fascinating and complex world of quantum mechanics. Quantum entanglement. Quantum entanglement refers to the phenomenon where two or more particles become connected and their state cannot be described independently of each other. It has been referred to as spooky action at a distance by Einstein, and remains one of the most mysterious aspects of quantum mechanics. When the particles are entangled, the behavior of one particle can affect the behavior of the other, even at great distances. Quantum entanglement has far-reaching implications, not only in our understanding of the universe, but also in practical applications. For example, it is the basis of quantum cryptography, which offers unparalleled security compared to classical cryptography methods. It is also the foundation of quantum computing, which has the potential to revolutionize the way we process and store information. Quantum entanglement is one of the many mysterious and exciting aspects of quantum mechanics, and has far-reaching implications in both fundamental physics and practical applications. The paradoxes of quantum mechanics. Quantum mechanics has always been a subject of great mystery and fascination for scientists, with its seemingly paradoxical behaviors and principles that challenge our classical understanding of the world. The Schrödinger's cat and the double-slit experiment paradoxes have been the subject of much debate and discussion among physicists and philosophers, and some believe that they point towards a deeper, more holistic understanding of the universe. Despite the many theories and explanations, the true nature of quantum mechanics remains shrouded in mystery, waiting for us to unlock its secrets. So, thanks for joining us on our quest to uncover the mysteries of quantum mechanics and explore the strange and wonderful world of quantum physics. Subscribe to the Black Screen Science channel. Like this video, and keep learning.